Hello, Spartan fans. In this video, we are going to talk about imaginary and complex numbers. So, if you'll recall in our last lesson, we were talking about the discriminant, which is b squared minus 4ac. And you'll find the discriminant as part of the quadratic formula. Okay, so it is the part underneath the root in the quadratic formula. And if what's underneath the square root is 0, the square root of 0 is 0, so that's going to mean one real solution. Solution also the same thing as the x-intercepts. And if b squared minus 4ac is greater than 0, then there's going to be two real x-intercepts. And then as a little side note, if b squared minus 4ac is a perfect square, that means the problem is factorable. Try to abbreviate here. Okay, and lastly, if b squared minus 4ac is less than 0, that would be a negative number. And so that means that whatever's underneath the square root would be negative something, and that leads to imaginary solutions. Okay, so let's talk about what imaginary numbers are. The square root of a negative, any negative number, so we're going to start with -1 because that's the easiest number to deal with. The square root of -1 is I, and that stands for an imaginary number. So for example, the square root of -4. I can break that down as, you don't need to solve these steps, I'm going to break it down for you. That's the same thing as the square root of -1 times the square root of 4. Well, the square root of -1 is I, the square root of 4 is 2, so we would say that the square root of -4 is 2i. Okay. So you can also say that I squared, so this is kind of funky. Let's look at what I squared would be. So the square root of -1 squared, that's kind of weird. So this would be the square root of -1 times the square root of -1, which is actually -1. So we say that I squared is -1. So if you're like, wow, why is it -1 and not +1? Okay, well, the square root of 2, let me change this here. The square root of 2 times the square root of 2 is the square root of 4, which is 2. The square root of 5 times the square root of 5 is the square root of 25, which is 5. So the square root of -1 times the square root of -1 is ends up being -1. Okay. So if I squared is -1, let's just stop there. We're just going to say that the square root of I squared is -1, and we'll get into more complexity later. Standard form of a complex number. Okay, so here we go. Standard form of a complex number. Standard form of a complex number is A plus BI. Hopefully you recognize A and B from when we've been doing lines. They're also part of when we're graphing quadratics. A is considered the real part of the number, and B is the coefficient on the imaginary number. So I could give you something like 5 minus 3i. So 5 is the real part. That would be our A. And negative 3 is the imaginary part. And that would be my B. So you can actually graph imaginary numbers. I know it's kind of strange, but you can graph a complex imaginary number. And it sounds super complicated, and I promise you it's actually quite basic. So instead of having an XY axis, we're going to have a real and an imaginary axis. So A is going to be considered like the X, and B would be considered the Y. So to plot the imaginary number 5 minus 3i, the A is 5, the B is negative 3, and it is actually just a point on an imaginary plane. I know that sounds so strange. So I'm going to plot the point 5, negative 3. And that would be here. And that is the complex number 5 minus 3i. We're going to do more with this as the year goes on. So let's plot the imaginary number. How about negative 1 plus 4i? So negative 1 would be your A, 4 would be your B, and this is the point I'm going to plot. And that would be right here. Okay. So let's do the quadratic formula and simplifying with some imaginary numbers. And what does this look like when I'm trying to graph a quadratic? Here we go. So let's take a look at y equals x squared plus 6x plus 10. You could complete the square if I wanted you to graph this. I'm not going to complete the square. So to graph this, if I wanted to find the vertex, you're going to start with the x coordinate is the opposite of b over 2a. You don't have to. I think you'll make less mistakes if you label what A, B, and C are. So in this problem, the x coordinate of the vertex is equal to negative 6 over 2 times 1, which is negative 3. All right, and then to find the y coordinate, I am going to plug in. That's going to be negative 3 squared plus 6 times negative 3 plus 10. So that's going to be 9 minus 18 plus 10, which is negative 9 plus 10, which I believe is 1. So the vertex of this parabola is negative 3, 1. So before I go any further, I'm just going to kind of look at a sketch of this graph. If the vertex is at negative 3, 1, and we're going to draw a nice pretty graph in the next section here, but negative 3, 1 is here. Notice that A is positive. So because A is positive, this graph is going to open right side up. I'm not drawing a perfect graph just yet. So if this graph opens right side up, its vertex is above the x-axis. This means that this graph has no x-intercepts. Okay, so if the graph has no x-intercepts, therefore, we say that they are imaginary. How do you graph imaginary x-intercepts with a positive on a real? You can't graph an imaginary x-intercept when you're on a traditional xy coordinate plane. So this is a traditional xy coordinate plane. I can only graph imaginary numbers if I am on a imaginary plane. So the imaginary plane A and B, but but right now I'm on the real plane, x and y. So how do I graph the imaginary x-intercepts? I don't, but I am still going to find them. Whether from now on, whether the x-intercepts are real or imaginary, you must find the x-intercepts from now until the end of the year. Whether they are real or imaginary, you have to find them. So you have to find them regardless if they are real or imaginary. So make a note to yourself when you're taking a quiz or a test or whatever, or you're doing your homework, you must find them. Okay, well, let's go for it. So we're going to plug into the quadratic formula and we're going to simplify this. All right, so here we go. So my x-intercepts, you're going to make y 0. All right, and again, you should always try and pause the video as I'm going through problems, see if you can do it on your own, and then turn the video back on and check your work. So in this case, it's going to be the opposite of 6 plus or minus the square root of b squared. Do you have to show all this work? No, but if you don't show the work and you make a mistake, I cannot give you partial credit. So this is going to end up being, I am going to skip a little bit of steps here, 36 minus 40, which is negative 4. This can be simplified. You cannot divide the 6 and the negative 6 and the 2. You cannot divide that yet. You must simplify the numerator first. So I'm going to continue over here. So that's going to be negative 6 plus or minus. The second you see a negative under the root, instantly it becomes an I right away. So the square root of negative 4 is 2I all over 2. Now you can reduce. Now you can reduce. So negative 6, 2, and 2 all divide by 2. So this is going to end up being negative 3 plus or minus I. And don't forget your notation. The only reason why x is negative 3 plus or minus I is because we made y 0. So those are your x-intercepts. Okay. So to graph this, I'm going to draw a nice big graph. My y-intercept was at C, which is 0, 10. So I'm going to actually change my y-intervals to make it fit. Your x and your y can be different intervals. That's no issue whatsoever. So the vertex was at negative 3, 1. Y-intercept was at 0, 10. I'm going to reflect and put the reflected point at negative 6. So my reflected point is at negative 6, 10. All parabolas have what we call an axis of symmetry. It always slices right through the vertex, boom, cut it in half. So the axis of symmetry always slices right through the vertex. So my reflected point, the y-intercept was 3 spaces to the right from the axis of symmetry. So I'm going to go 3 spaces to the left, and hence that's where I got negative 6, 10. Okay, let's check our work. I know, checking our work, what a pain in the butt, but we are going to check our work. So to check my work, we said that the x-intercept was at negative 3 plus or minus I. So to check, that means that when I plug this in, I should get 0 for y. Okay, so I'm going to plug in negative 3 plus I. I just think it's a little bit easier than negative 3 minus I, whatever. So when I check this, the original problem was x squared, I believe, plus 6x plus 10. Let me just double check that was plus 6x and not minus 6x. Great. So when I plug this in, do I get 0? So x, which is negative 3, I'm just going to use plus I to check. You can check negative 3 minus I if you want. And be careful, in the homework, it specifically says in the directions to check your work. So if you don't check your work, you're not going to get full credit. When you square a number, multiply it by itself. I'm going to distribute. So when you multiply out negative 3 plus I times negative 3 plus I, make sure you're distributing. So this becomes 9 minus 3I minus 3I plus I squared minus 18 plus 6I plus 10. Okay, so when we combine like terms, this is going to be negative 3i, positive 6i, that's 0. So now I've got 9 plus I squared minus 18 plus 10. Okay, well, going back, I squared is negative 1. So now I've got 9 minus 1 minus 18 plus 10, which does indeed equal 0. I hope so. 8 minus 18 is negative 10. Yeah, that works. Okay, so A plus BI, a little summary here. A plus BI is considered a complex number. It's complex. It's got real and imaginary mixed in together. It's a complex number. Square root of negative 1 is I. Negative 1 is the equivalent of I squared. The discriminant, B squared minus 4AC. Okay. And I think that will be enough to get you through your homework. We will go over all the homework when I return to class. I'm at a conference, a professional development thingamajigger today, so I will be back next class period. Your homework will be, and it should be on the board, I wrote it on the board for you, but just in case, your homework is going to be page 193, number 1 through, let's see here, 1 through 17, every other odd. And then for problems 1 through, I'm trying to do this off the top of my head, it's not going very well. 159, I also want you to graph. Homework, page 193, and then for 159, I want you to graph. And so graphing means every time I want you to graph vertex, y-intercept, x-intercept, real or imaginary, and a reflected point. Reflected, symmetric, same thing. More than enough time to get all of that done in class today.